this video, we are going to see how to install and use Icarus Verilog to describe digital circuits using the Verilog hardware description language. Installing Icarus Verilog in a Linux computer is very easy because it's natively designed to run in Unix-like operating systems. So Icarus Verilog and the Gtkwave waveform viewer are included as a standard package into most modern Linux distributions. So here I'm going to use Ubuntu Linux, which is a very popular Linux distribution, and the instructions are mostly the same for any Debian-based Linux distribution. But if you use another version, just use your package manager and find the Icarus Verilog or iVerilog package. So this video is for people already using Linux systems. For people that are already users of Linux, it must not be a problem to find any package. But this video is also for people that want to try Linux to run Icarus Verilog. So if it's the first time you are going to use the system, then you have many options. You can go to a mainstream distribution like Ubuntu Linux and see the instructions to install the system. Or if you just want to try, you can download an image for a virtual machine, and you can run your system in a virtual machine, and you can try the system and also find that it's very easy to install Icarus Verilog there. Okay, this video, for example, is run in a virtual machine using only 2 GB of RAM memory. So also a good option is it doesn't consume many resources in a modern computer. And it's also a good option if you have an old computer that you don't use very much anymore. If it's not powerful enough to run other operating systems, it should do fine with Linux distribution. So the easiest way to install it is, in the case of Ubuntu Linux, Icarus Verilog is in a package named iVerilog. Because Icarus Verilog is the Verilog compiler and Verilog simulator, and it doesn't have a graphical interface. It's normally not listed in the main package manager in Ubuntu. So the easiest way to install it is just from a terminal. You can open a terminal window. If you don't have a link, you can search for a terminal window somewhere, and there you install it using the command line package manager apt. So you write sudo apt install iVerilog. Okay, and now we are going to install the Gtkwave package that includes the waveform viewer. That is going to be very useful to check the results of my simulations. So just write your password and then let the system download and install everything. As you see, it will take only a few seconds. Okay, and that's it. It's installed. Now, to start designing Verilog circuits or circuits using Verilog, you need some basic tools. You need a file manager just to handle your files. Okay, so you should find a place where to save your project. For example, I'm going to create a folder. Hello. Verilog for my project, and I'm going to do a small example here. So the file manager will be used to handle your files. Then Verilog code is just text, as in other programming languages. So you can simply edit that text with a text editor. You can use the standard text editor with your system. In the case of Ubuntu, you can find it, it's named text editor. Actually, this is the program gedit. And there you can start your Verilog code. In my case, I'll write a very simple module. I'm going to call it hello world. I will save the document. I'll use the folder for my project. I'll call it hello.v. .v is the extension for Verilog files. And yes, I will define a module. Hello. With no inputs and outputs. And in my module, I will just print a message. Okay. And module. It displays a system function in Verilog that works like a print in other programming languages. As you can see, the standard text editor in Ubuntu already knows about the Verilog syntax. Okay, so it's very convenient. We save our file. Okay, now we have Verilog code here that we want to test. Now it's when we use Icarus Verilog. So Icarus Verilog is run from a terminal. It's only works in the command line. It doesn't have a graphical interface, but it doesn't really need one, because what all it does, or what Icarus Verilog tools do, is to check and compile our Verilog design and then simulate the design. Okay, so first we need to change our working directory in my terminal to the folder I'm using. It's done in the terminal with the cd command. So basically we write cd, and now the path to the folder we are using. The easiest way to do that is to take the folder in our file manager and drop it on the terminal, so it will complete with the path to the folder. So cd command, name of the folder, enter, and then we are working in the folder with our project. We don't really need to know many terminal commands, but a useful one also is ls, just to list the content of the folder, just to check that we are working in the right folder. We can see our file here. Now, Icarus Verilog uses two main commands. One is iVerilog, which is the compiler. It will take our text and convert into something that can be simulated. And when doing so, it will also tell us if we have some syntax errors. And so we can check it and correct the code. So we simply write the names of the files we want to compile. We can compile many files at the same time with different modules in our complex project. So we see we have a syntax error in line 5. Okay, so at some point I made some mistake. So let's try. Yes, my mistake is that I missed a semicolon after the definition of the module, I think. Okay, so I correct that, save my program, and I execute the compiler again. In a regular terminal, you don't have to write the command again. You can use the cursor arrows to the app, so we can recover the previous commands and just execute again. Okay, this is still an error there. And yes, it's also my fault because I have used display, but display keywords have to be inside some kind of procedural description. Okay, so we use an initial procedural description and it will go inside it. Okay, so after solving the error, now the command doesn't say anything. As the result, if the compilation goes fine, it will generate a compile design. By default, it's named a.out, and this is the thing we can simulate. The simulator is also included with Verilog package and is called VVP, and then we pass the simulator our compile design file, VVP a.out. And when we execute this module, the simulation of this module is just display the message. Okay. So with this, we have a basic Verilog design environment. Okay, we can handle my files, write Verilog code, compile and simulate the code. Now, if you want to learn Verilog, there are many resources on the internet. You can check my Verilog course based on examples that you can find in GitLab. So you have the address here, and this is a course starting from the very beginning, covering the typical content of an introduction to digital design using Verilog. Okay, it's good if you are already studying digital design, or if you already know the basics of digital design and you want to get an introduction to Verilog. So the course is very easy to use. You basically download everything and then go to the Verilog folder and start with the first unit and the first lesson in the unit. Okay, so you just follow everything in order and you will find examples with a very long descriptions of what is done in every example. So the example is something you can execute, you are proposed exercises to be modified, and all the content is included as comments inside the example. So you just go into the example, open the files, compile them, and follow the instructions. That's it. Okay, thank you. Bye.